I've made some adjustments to the procedural track discussed in a previous video. I've applied a triplanar material to the ballast in order to reduce tiling. I've also separated the rail collision from the rail meshes. The order in which the procedural track is built has remained largely the same. The number of track sections in the length of the spline is calculated. For each section, the start and end locations and tangents are found. These values are used to create the ballast, the sleepers, the rails, and the rail collision. Note that the collision mesh is set to not be visible. I'm still using a setup with 2 sphere colliders per bogie that sit in between the rail collision meshes. The switch is based on the same principle as the track, but this time with 2 splines. The points mechanism mesh is placed on one side or the other of the track based on a Boolean variable. The length of spline 01 is used to calculate the number of sections it contains, and each section's start and end locations and tangents are calculated. Next, each section's ballast and sleeper is created based on those values. An integer variable is used to record where the 2 tracks split. If this variable is 0, it means that the 2 splines are not yet a full track gauge apart, and that the split has not yet happened. Any collision meshes located between the points mechanism and the split need to be movable, so that either the left branch or the right can be moved into place depending on the position of the points. Depending on the Boolean values fed into the createRail collision function, collision meshes are created and parented to either the left or right collision mover C node. Manual attachment is checked on creation, or to the root scene node. Manual attachment is not checked. The meshes are set to not be visible in game, but can be set to be visible for troubleshooting. As the tracks have not yet diverged, a single rail is placed along that section. To check for where the 2 tracks diverge, the distance between them at each section is measured, and the split section integer is updated only when that distance is greater than the track gauge. Next, the point halfway between the splines is calculated, and the C node that will be involved in the movement of the points is moved to that location. At this stage, there is enough information to hand to create both points. A distance to split variable is set to the distance from the origin to where the tracks diverge. A new spline component is created, named left spline, and its location at point 0 is set to half the track gauge away from spline 02 at the split location. Left spline's tangent at point 0 is set to the inverse of the tangent at spline 02 at the split location. Left spline's location at point 1 is offset from the 000 point of the junction, and left spline's point 1 tangent is set to the inverse of spline 02's tangent at point 0. A spline mesh component is added to represent the left point. Manual attachment is checked, and its start and end locations are calculated and set, taking into account the offset of the points mover C node from the origin of the turnout. Finally, the left point mesh is parented to the points mover C node. This process is repeated for the right hand point based on spline 01's locations and tangents. The base of the frog is placed at the point where the tracks diverge and rotated to look at the origin of the turnout. The length of the guardrails is calculated as a fraction of the distance from the origin of the turnout to where the tracks diverge. Returning to the check on the split section variable, if it is not 0, then the point of divergence has been calculated and a check is performed whether the current section is the section at which the guardrails end. If it is, the guardrails for spline 01 are created based on the split section and guardrail end section variables. The start and end locations and tangents are calculated, and a spline mesh component added to represent the guardrails. Incoming sensor 1 is a box collision that senses when an actor is on the spline 01 left hand track and causes the points to move to the correct position to allow a vehicle through. its location is set to the end of the guardrails on spline 01. Irrespective of whether the guardrails are drawn in this iteration of the loop, the appropriate number of rails is drawn for this section and the appropriate type of collision created. Once all of the sections along spline 01 have been dealt with, the sections for spline 02 are created. The number of sections along spline 02 is found, and each section's start and end locations and tangents calculated in a for loop. Then the ballast and sleepers are created, and a check is done to see whether or not the current section is before or after the place where the tracks diverge. If it is before, this section's collision is parented to the collision mover 02 scene node, and a single, right-hand, rail is drawn. If, on the other hand, this section is beyond the point at which the tracks diverge, a check is performed to establish whether this is the guardrail end section. If it is, guardrails are created for spline 02, and the sensor for spline 02's track is placed at the end of the guardrails. Finally, the rail, or rails, and collision are created as required for this section. In the event graph, begin play is used to get a reference to the points lever, if it exists, and to calculate the angle of rotation required for the points based on their length. The swap collision event is declared in the BPI animations blueprint interface and is called by the points lever. This causes one set of collisions to be moved out of the way of the vehicle and the other to be raised into position to guide the vehicle along the appropriate set of rails. The set anim progress event is also declared in BPI animations and called by the points lever as it rotates from one detent to another. When the incoming sensor 1 detects an overlap, it calls the snap to lowest detent function on the points lever. This function is declared in BPI interact. The is switching boolean is used to prevent the function from being called multiple times for a single overlap. The overlap of incoming sensor 2 calls snap to max detent on the points lever. The points lever inherits from the interact item blueprint class and uses the BPI interact blueprint interface. The snap to lowest detent and snap to max detent events both call the switch's swap collision function and feed in a boolean to indicate which collision is to be raised and which moved out of the way. The overridden move item event also calls the swap collision function on the switch. While the lever is animating, using timelines, it calls the set anim progress function on the switch, driving the rotation of the points mover scene node. For the crossover in this example, both switches have their public boolean set to true. The points are set to manual and the points mechanism is on the right hand side of the track.